Good day, everyone. In this video, I'll be talking about the relationship between density, specific gravity, mass, and volume. So if you're curious about why some things float, sink, or feel heavier than others, keep watching. Density, specific gravity, mass, and volume. These four are basic physical properties that are connected through simple formulas. Understanding them helps explain why objects sink or float, or why some things feel heavier even if they look small. So, let's start with mass. Mass is the total amount of matter in an object, basically, how much stuff is inside it. It doesn't change whether you're on Earth or the moon. The symbol for mass is m and its SI unit is kilogram. For example, if you have a 1 kilogram bag of rice, that's its mass, no matter where you bring it. Next is volume. Volume tells us how much space an object takes up. The symbol is V and the SI unit is cubic meter or liter, which we often use for liquids. For example, a soda labeled 330 ml has a volume of 0.00033 cubic meters. Cool, right? Now we go to density, one of the most important ones. Density shows how much mass is packed into a certain volume. The symbol for density is the Greek letter ρ or P. It kinda looks like a curly P. The SI unit is kilogram per cubic meter or gram per cubic centimeter. Here's an example. Water has a density of 1000 kilogram per cubic meter, while oil has about 920 kilogram per cubic meter, which is less dense. That's why oil floats on water. Next is specific gravity, or SG for short. Is the ratio of a substance density to the density of water at 4 degrees Celsius. It doesn't have a unit, it's just a comparison. If the SG is greater than 1, the object sinks. If it's less than 1, it floats. For example, the specific gravity of ice is 0.92. That's why ice floats in your drink. So, how are they related? Mass and volume are the base quantities. When you divide mass by volume, you get density. That's the formula. Density is equal to mass over volume. If you rearrange it, you can find mass using mass is equal to volume times density, or volume using volume is equal to mass over density. And when you compare a substance density to water's density, you get specific gravity, or SG is equal to density over density of water. So they're all connected like a small family of formulas. So here's a quick summary. Mass is the amount of matter, volume is how much space it takes, density is how tightly packed the mass is, and specific gravity compares density to water. You'll see all the symbols, formulas, and units here for review. Feel free to pause the video and take notes. And now, let's try to solve problems. Problem number 1. A block has mass 200 grams and volume 50 cubic centimeter. What is its density? Feel free to pause the video and give it a try. Now, let's write the given first. Mass is 200 grams. Volume is 50 cubic centimeter. Next, the formula. Since we're looking for density, the formula we'll be using is density is equals to mass over volume. Now, the solution. Let's substitute. Density is equal to our mass, which is 200 grams, divided by our volume, which is 50 cubic centimeter. So 200 divided by 50 is equals to 4. Now our units. Grams over cubic centimeter gives grams per cubic centimeter. So therefore, our density is 4 grams per cubic centimeter. Problem number 2. A liquid has density 800 kilograms per cubic meter. What is its specific gravity? Feel free to pause the video and give it a try. Let's write the given first. We are only given the density, which is 800 kilogram per cubic meter, and we need to find its specific gravity. So we'll be using the formula Sg is equal to density over the density of water. Now, let's substitute. Specific gravity equals to our given density, which is 800 kilogram per cubic meter divided by the density of water, which is 1000 kilogram per cubic meter. 800 divided by 1000 equals to 0.8. Specific gravity has no units. It's a ratio. So specific gravity is equals to 0.8. Since specific gravity is less than 1, this liquid would float on water. It's less dense than water. Problem number 3. If density is equal to 2 grams per cubic centimeter and volume is 10 cubic centimeter, find the mass. Feel free to pause the video and give it a try. Let's write the given first. Our density is 2 grams per cubic centimeter and our volume is 10 cubic centimeter. Since we are looking for the mass, we are going to use the formula mass equals to density times volume. Now let's substitute. Mass is equal to our density, which is 2 grams per cubic centimeter, multiplied by our volume, which is 10 cubic centimeter. So 2 times 10 is equal to 20. And for our unit, cancel cubic centimeters and grams is left here with us. So our final answer is 20 grams. Problem number 4. A metal has mass 5 kilograms and density 2,500 kilograms per cubic meter. What is its volume? Feel free to pause the video and give it a try. Let's write the given first. So we have our mass 5 kilograms and density 2,500 kilograms per cubic meter. And here, we are going to find the volume. So to find the volume, we'll use the formula volume equals to mass over density. Now, let's substitute and solve. Volume is equal to our mass, which is 5 kilograms divided by our density, which is 2,500 kilograms per cubic meter. So 5 divided by 2,500 equals to 0.002. And for our unit, we cancel kilograms, so cubic meter is left here with us. So our final answer is 0.002 cubic meters. Problem number 5. A rock's density is 3.2 grams per cubic centimeter. Will it sink or float in water? Since we only need to find out whether the rock will sink or float in water, we will find its specific gravity using the formula specific gravity equals to density over the density of water. Now let's substitute. Specific gravity is equal to our given density, which is 3.2 grams per cubic centimeter, divided by the density of water, which is 1.0 gram per cubic centimeter. So 3.2 divided by 1 is equal to 3.2. And since our specific gravity is greater than 1, it means the rock will sink. And that's it for my report on density, specific gravity, mass, and volume. I hope this video helped you understand how they're connected, and how to use the formulas easily. If you learned something, don't forget to give this video a like, and thank you so much for watching. See you next time!